On the 7th of July, 2022, Iowa closed the swimming beach at Lake of Three Fires State Park in Taylor County. A visitor from Missouri had swum there in late June and was dead by the 7th. What is strange is not that it happened. It is where. The organism that killed them cannot function below about 86 degrees Fahrenheit, which is why this was a southern problem for 40 years. Yet, its northern edge, on the CDC's own map, has climbed roughly 8 miles a year since 1978. How far does that line go, and how close is it to your water? All of it runs through one opening in the human skull, so that is where this has to start. Naegleria fowleri is a single-celled amoeba, about 22 microns long in its feeding form, and it lives in the warm, shallow sediment of lakes, ponds, reservoirs, and slow rivers all over the world. It gets into a human being one way. Warm, fresh water has to go up the nose with enough force to reach the roof of the nasal cavity. Not the throat, not the lungs. The very top of the nose, where the olfactory nerve comes down out of the skull. At that spot, there is a piece of bone called the cribriform plate. Louisiana's state epidemiologist at the time, Raoult Retard, described it to NPR in 2013 as a paper-thin plate with a bunch of holes in it, a little bit like a mosquito net. The holes are there so the olfactory nerve can pass through and give you a sense of smell. They are not a defense. They are an opening in the floor of your skull that exists for a completely unrelated reason. The amoeba penetrates the olfactory mucosa, follows the olfactory nerve fibers up through those holes, and arrives in the olfactory bulbs of the brain. Go back over that sequence, because something is missing from it. The blood-brain barrier. The layer of tightly sealed cells that keeps almost every pathogen in your bloodstream out of your central nervous system. Naegleria fowleri does not break through the blood-brain barrier. It goes around it. That is the whole trick, and it is why this organism is so much worse than its size suggests. Most things that reach a human brain have to win a fight to get there. This one walks a corridor that was already open. Now the part that gets reported wrong constantly. You cannot catch this by drinking the water. The Centers for Disease Control and Prevention says so plainly, and swallowing water containing the amoeba does not cause infection. Your stomach handles it without incident. There is no recorded case of one person passing it to another, anywhere, ever. A boy can swallow half a lake and be completely fine. Water forced up his nose while he cannonballs off a dock is a different event entirely. And it is not hunting you either. In the sediment where it lives, Naegleria fowleri eats bacteria. That is its job, and that is its diet. A human skull is a dead end for it. The amoeba that gets into a brain cannot get back out, cannot infect anyone else, and dies with its host. Everything that happens inside that skull is an accident from the amoeba's point of view, which raises a question researchers still cannot answer. If the brain is a mistake, why does the amoeba go up the nerve at all, instead of staying in the nasal tissue where the bacteria are? The leading idea appeared in the journal ACS Chemical Neuroscience. The amoeba carries a receptor on its surface that is structurally similar to the human muscarinic M1 receptor, the one that binds acetylcholine. Acetylcholine is a neurotransmitter, and it is abundant in nerve tissue. The proposal is that when the amoeba damages the olfactory mucosa, it gets exposed to acetylcholine leaking out of injured nerve endings, and it follows that chemical gradient the way it would follow a trail toward food. In effect, it swims up the smell of a nervous system. That explanation is worth stating carefully, because the researchers state it carefully. It is a hypothesis. It has not been proven. Anyone who tells you flatly that the amoeba smells your brain and hunts it is going further than the published science goes. What is established is where it ends up, and what it does when it gets there. What it does is fast. Symptoms usually begin 2 to 8 days after the water went up the nose, occasionally as soon as 24 hours, occasionally as long as 2 weeks. They start with a severe headache at the front of the skull, fever, nausea, and vomiting, then a stiff neck, confusion, seizures, hallucinations, coma. The CDC records death anywhere from 1 to 18 days after symptoms begin, with a median of 5. The nickname is misleading about the actual cause of death. The Amoeba does destroy tissue directly, releasing enzymes that break open cell membranes, but what kills the patient in the end is swelling. The brain inflames, pressure inside a rigid skull climbs, blood flow to the tissue drops, and the brain is forced downward against the base of the skull. A large part of that inflammation is your own immune system arriving in force at a place where there is nowhere for the swelling to go. And on a hospital chart, every bit of that looks like bacterial meningitis. That is why so many of these cases are confirmed after the funeral. Look at what happened in Pulaski County, Arkansas, in September 2023, written up by the CDC in Morbidity and Mortality Weekly Report. A previously healthy 16-month-old arrived at a local hospital on the 1st of September with fever, vomiting, and altered mental status. A CT scan showed swelling. Spinal fluid came back looking like bacterial meningitis, so the child was treated for bacterial meningitis. Cultures grew nothing. On the 3rd of September, a pathologist looking at a stained cytospin slide of that spinal fluid saw amoeba moving in it. Treatment for Naegleria fowleri started that day. The child died on the 4th of September. The CDC confirmed the organism by PCR on the 6th. On the 28th of September, the lab matched the genotype from the child's spinal fluid to a swab taken from the tank of a splash pad the family had visited on the 26th and 27th of August. 3 days from hospital door to death, then 24 more days before anyone could say where it came from. That gap is the entire clinical problem with this disease. And the treatment on the other side of that gap is thinner than you would expect in 2026. There has never been a randomized trial of any therapy for this infection because the disease is far too rare and moves far too fast to run one. What doctors use instead is a combination assembled from the handful of survivor case reports and from laboratory work on what kills the organism in a dish. Conventional amphotericin B, given intravenously and sometimes injected directly into the spinal fluid. Rifampin, fluconazole, azithromycin, miltefosine, which the CDC began supplying directly to hospitals in 2013. Dexamethasone for the swelling. The survivors also received therapeutic hypothermia, meaning their body temperature was deliberately lowered to buy the brain room. Reported courses of treatment run somewhere between 9 and 30 days. Set that against a median of 5 days from first symptom to death, and you can see the shape of the problem. Most of the time, the correct treatment is identified after the window to use it has closed, which is why the survival number is what it is. Between 1962 and 2024, the United States recorded 167 cases of PAM. 4 people survived. More than 97% of everyone who has developed this infection in this country has died of it. And at least one of the 4 survivors was left with permanent severe brain damage because treatment started too late. Before this goes any further, North, I want something from you. Say the name of the water you are closest to right now. The lake, the river, the reservoir, the pond behind somebody's house. Put it in the comments with the state, because by the end of this video, you are going to want to know which side of the line you are on, and I want to see how far this map actually reaches into this audience. Because the line is the story, and to understand why it moves, you have to understand that this organism has almost no defenses and one enormous advantage. Naegleria fowleri lives in 3 forms. The first is the trophozoite, the feeding and dividing stage, and the only stage that infects people. The second is a flagellate, a swimming form it switches into when nutrients run low and it needs to travel. The third is a cysty, roughly 7 to 12 microns across, sealed and metabolically inactive. And this is the one that matters for the map. Cold does not kill this organism. Cold makes it encyst. When lake temperature drops in autumn, the amoeba pulls itself in, seals up, sinks into the sediment, and stops. It is still alive down there, dormant in the mud, and when that sediment warms again the following summer, it opens up and starts feeding. So the question was never whether it can survive a northern winter. Northern winters are not the barrier. The barrier is the summer. Here are the numbers that decide everything else in this video. Naegleria fowleri proliferates in water above 30 degrees Celsius, which is 86 degrees Fahrenheit. It tolerates temperatures up to 45 degrees Celsius, 113 degrees Fahrenheit, hotter than almost any lake in North America ever gets. And it does not survive in salt water at all. Hold that 86-degree figure, because it explains the entire historical shape of this disease. A shallow, still, southern lake in late July crosses 86 degrees easily. Water in a Minnesota lake in a normal summer does not. That single threshold is why the CDC map of 173 PAM exposures by state is so lopsided. Texas and Florida lead it by a wide margin, followed by Virginia and California. That has nothing to do with how carefully anybody down there swims. Their water spends more days a year above the number at which this organism can function. The seasonal data says the same thing from another angle. Of the 157 American cases with a known month of illness onset, they pile up in July and August. Not May, not October, but the two hottest months of the American year. And there is one more pattern buried in that data set, and it is not subtle. The largest single group of cases in CDC's records, 45 of them, is males between 10 and 14 years old. Nobody has found anything about a 12-year-old boy's immune system that invites this infection. What that number is measuring is behavior. It is who jumps in feet first, who does backflips off the dock, who dives down and stirs up the bottom, who stays under the longest, who goes back in 6 more times in one afternoon. CDC's prevention guidance points at the same thing from the other end, because it tells you plainly not to dig in the shallow water, since the amoeba is more likely to be living there. The organism concentrates in the warm, shallow bottom. The behavior that drives water up a nose at pressure is jumping, diving, and thrashing in exactly that shallow bottom. Those two things overlap almost perfectly on the hottest weekends of the year, and that overlap is most of the American case list. Which brings this back to Iowa. In the 2 weeks the Missouri visitor was swimming at Lake of Three Fires State Park, a weather station near the park recorded highs around 95 degrees on 2 consecutive days over the July 4th holiday. CDC says infections usually occur when it has been hot for prolonged periods, which raises water temperature and drops water level. A shallow southwest Iowa lake sitting under 95-degree air for days on end is not really a northern lake anymore in any way the amoeba cares about. For those few days, it is a Gulf Coast lake that happens to be in Iowa. But weather is not the only thing that can push water past 86 degrees. And this is the part of the story that has nothing to do with lakes at all. This is not about natural water alone. In 2020, and again in 2021, 2 young children in Texas died of this infection after playing at splash pads, not lakes. Municipal water features with pumps and tanks and chlorinators, the kind of thing a city puts in a park so kids can run through jets of water on a hot day. Both were investigated. Both involved water that was not adequately disinfected. The Arkansas case from 2023 that we walked through earlier was the 3rd of those in 4 years. The Arkansas investigation is worth hearing in detail, because it is the clearest picture anyone has of how this happens in engineered water. Inspectors found the pH of the splash pad water reading above 8.2, which was the ceiling of the test kit, meaning nobody actually knew how high it was. High pH cripples. How well chlorine kills anything. The chlorinator, the device that is supposed to add disinfectant automatically, had been reported non-functional for roughly a month. Chlorine was being added by hand, once a day. And there were no daily operating records at all, so there was no way to reconstruct what the water had been doing. Inside the storage tank, they found biofilm. Biofilm feeds free-living amoeba and shields them from disinfectant. Then there is the tap. Cases in Louisiana and the U.S. Virgin Islands have been traced to people rinsing their sinuses with untreated tap water, which pushes water straight to the top of the nose by design. One Louisiana case was linked to a backyard slide hooked up to a household faucet. In 2013, the amoeba was found in an American municipal water supply for the first time. So, the honest version of the mechanism is broader than a warm lake. This organism needs water above 86 degrees with something living in it to eat, and a route into the top of somebody's nose. A July heat wave over a shallow reservoir supplies that. So does a broken chlorinator on a 100-degree afternoon in a city park. Now, here is where the guessing stops and the measurement starts. In January 2021, CDC researchers published a study in Emerging Infectious Diseases, with Radhika Gharpure as lead author, that did something nobody had done with this disease before. They took every PAM case reported to CDC between 1978 and 2018, 120 of them, and pulled out the 85 with a single identifiable recreational water exposure in a lake, a pond, a reservoir, a river, or a stream. Then, instead of counting cases, they mapped latitudes. They asked two separate questions. Where is the northernmost exposure in each year, and where is the southernmost? Then they ran a regression on both across 4 decades. The southern edge did not move. Zero meaningful change, and the statistics say so. The northern edge climbed 0.12 decimal degrees every year. That works out to about 13.3 kilometers, a little over 8 miles north per year, sustained for 41 years. Sensitivity analyses confirmed the trend held up when they pulled out the years with only one case, and when they pulled out the statistical outliers. 8 miles a year does not sound like much. Run it across the whole study period, and the northernmost documented exposure in the United States moves roughly 350 miles. That is the distance from Dallas to the far side of Oklahoma, or from Memphis up into southern Illinois. And the regional data underneath that average is far more specific. In 41 years, the entire American Midwest recorded 6 of these exposures. 5 of the 6 happened from 2010 onward. Here they are in order. Minnesota in 2010, Kansas in 2011, Minnesota in 2012, Indiana in 2012, Kansas in 2014. 32 years produced 1 Midwestern case. The 5 years after 2010 produced 5. Those 2 Minnesota entries deserve a much longer look than they usually get, because they came out of the same body of water. Lily Lake sits inside the city of Stillwater, Minnesota in Washington County, east of St. Paul, and close enough to the Wisconsin border that you could throw a rock at it. It is a small municipal lake with a swimming beach, the sort of place a town puts a lifeguard chair and a rope line and a sign about glass bottles. In August 2010, a 7-year-old girl who had been swimming there died of primary amoebic meningoencephalitis. In August 2012, a 9-year-old boy who had been swimming at the same beach died of the same infection. Those 2 children are the northernmost confirmed cases in the history of the United States. Not a Texas reservoir or a Florida canal, but a city beach in eastern Minnesota, at a latitude where the lakes were supposed to be too cold for this organism to be active at all. The infectious disease paper that documented the first one carried a subtitle that reads like a warning label describing a possible expanded range of a deadly thermophilic organism. Stillwater closed the beach at Lily Lake, and it has stayed closed ever since. If you have made it this far, you are the kind of person who wants the real version of this rather than the scary version, and the real version takes longer to make. Subscribe, because that is the whole point of this channel. Real cases, real biology, real places in America's own water. The Gharpure study found one more thing worth sitting with. For the 85 exposures where a date could be established, the researchers pulled temperature records from the nearest weather station and compared the 2 weeks before each exposure against the 20-year average for that same place on those same calendar days. Daily highs ran about 3/4 of a degree Celsius warmer than the historical average. Daily lows ran warmer by about the same amount. Small numbers, consistently in one direction, across 4 decades of cases. Now comes the part that most coverage of this organism leaves out entirely, and this is where an honest video and a viral one-stop agreeing. Across those same 41 years, while the northern boundary was climbing 8 miles a year, the number of Americans getting this infection did not go up. The researchers ran the test and reported the result in the paper. No detectable trend in annual incidence, a relative risk of 1.015, and a p-value that fails significance by a mile. Between 1978 and 2018, PAM cases from recreational water ranged between 0 and 6 a year, and that range at the end of the period looked much like the range at the beginning. So the map got taller without the pile getting bigger. Whatever is happening here, it is not that this organism is exploding across the country. And there are at least 3 solid reasons to hold the northward finding loosely. The first is a confounder, the authors named themselves. A hotter summer does not only warm the water, it also puts far more human beings into it. More hot days means more swimming, more diving, more time submerged, more chances for the one exposure that matters. Some unknown share of that northward shift may be people expanding into water that was always marginally warm enough. The second reason is a detection problem, and it is bigger than it sounds. PAM is not a nationally notifiable disease in the United States. CDC tracks it through the voluntary cooperation of state health departments, and CDC says outright that the infection is probably under-recognized and underreported. A separate CDC analysis, published in 2018, went looking specifically for how many cases go undiagnosed in this country, and concluded that the recorded number is not the real number. Think about what that does to a map. For a case to land on it, a person has to die in a hospital, where somebody thinks to look at the spinal fluid under a microscope instead of assuming bacterial meningitis, and a sample has to reach one of the very few laboratories in the country able to confirm it. If a child in Alabama died of meningitis in 1985, a doctor in that state might have had a reason to consider amoeba. If a child in Minnesota died of meningitis in 1985, nobody had any reason at all. So, part of what that climbing line is tracking may be nothing more than the medical system slowly learning where to look for it. The third reason is the most interesting, and it is the one I would want somebody to point out to me if I were making the argument. In 2024, a study published in ACS, ES, and T Water reported the first detections of Naegleria fowleri in the hot springs of Grand Teton National Park in Wyoming, with the highest concentration, roughly 116 cells per liter, at Polecat Hot Springs. On a map, that is a dot further north than anything else in this video. It also proves nothing whatsoever about climate. A hot spring is heated from below by geothermal energy. It sits above 86 degrees in January. It was above 86 degrees 1,000 years ago. Finding a heat-loving organism in geothermally heated water tells you the organism travels and colonizes warm water wherever warm water exists. So if you see that Wyoming dot used as evidence that the amoeba is marching north, it does not belong there. Geothermal water is warm on its own terms. It is worth looking outside the country too, because it puts the American numbers in proportion. In 2023, Pakistan documented 147 cases of this infection in a single year, concentrated around Karachi. Researchers attributed the surge to heavy monsoon flooding and to inadequate chlorination of the municipal water supply. 147 cases in 1 year in one metropolitan area, compared with 167 in the United States across 62 years. And what drove that surge was the state of the municipal plumbing rather than the temperature of any lake. So, put the honest numbers on the table, all of them at once. Between 1937 and 2025, the United States diagnosed 180 cases of primary amoebic meningoencephalitis. Total. In 88 years, the annual count has run between 0 and 8. In the 10 years from 2012 to 2021, 31 Americans were infected, against millions of recreational water exposures every single summer. CDC puts that next to a comparison it chose itself, which is that in each of those same years, roughly 4,000 people in this country died from unintentional drowning. You are vastly more likely to drown in that lake than to be infected in it, and it is not close. Both halves of that are true at the same time, and that is the part that keeps getting lost. The northern boundary of documented exposures really has climbed for 4 decades, and the CDC's own stated position is that the range of Naegleria fowleri appears to be expanding northward, possibly as a result of warmer temperatures. And your personal odds of this happening to you are so small, they barely register. Both of those sentences come from the same agency, on the same website, and you almost never see them quoted together. What that leaves you with is a small, unglamorous set of things that actually work, and every one of them is about the nose. Hold your nose or wear a nose clip when you jump or dive into fresh water. Keep your head above the surface in hot springs. Do not stir up the sediment in the warm shallows, because that is where the organism concentrates. And if you rinse your sinuses at home, use distilled or boiled water, never straight from the tap. That last one has killed people who never went near a lake. None of that requires you to stop swimming. It requires you to keep water out of the top of your nose in warm, shallow, fresh water in July and August, which costs you nothing at all. The seasons since Iowa have kept the pattern going. In July 2025, the South Carolina Department of Public Health confirmed a case traced to Lake Murray, the state's first since 2016. In August 2025, the Missouri Department of Health and Senior Services confirmed a case in an adult who had been water skiing at the Lake of the Ozarks. That person died on the 19th of August at a hospital near St. Louis. Water skiing, not diving, not swimming underwater, just going over the surface fast enough to force water upward. So, back to that beach in Taylor County. Iowa closed Lake of Three Fires on the 7th of July, 2022. State agencies sampled the water alongside the CDC and confirmed that Naegleria fowleri was living in the lake. And then, on the 28th of July, 2022, the Iowa Department of Natural Resources reopened the beach. That was not carelessness. The CDC does not recommend closing natural bodies of water when this organism is found, and the stated reason is the same. Finding this entire video has been circling. Naegleria fowleri is common in warm, fresh water. The infection it causes is rare. Closing every lake that contains it would mean closing a very large share of the water in the American South, and now a growing number of lakes further north, and you would still not prevent the handful of cases that occur every year. So the beach opened again, with signs at the water telling people what was in it and how to keep it out of their nose. That is where this actually ends. Not with a lake nobody swims in, but with a warm, shallow beach in southwest Iowa, in a state that spent a century assuming its water was too cold to matter, where families still spread out towels on a July afternoon. The water there looks exactly the way it looked in June of 2022. The only thing that changed is that now there is a sign. And if a lake in Taylor County, Iowa needed one, the question worth sitting with is which lake gets the next sign and how far north of there it is going to be.